In this lecture, I'm going to cover refraction, which I mentioned briefly in previous lectures. So far in this unit, I've been discussing wave behaviors which are exhibited when a wave encounters a new medium of propagation, for instance, some glass. So far, I've only discussed reflection, which is a type of behavior exhibited when a wave encounters a medium which it does not pass through. Instead, it bounces off this medium. Refraction is different. Refraction occurs when the wave does pass through the second medium, perhaps not completely, but at least in part. I'll discuss this more in the next slide. First, let's consider a simple example. Let's say we have a light wave traveling at some angle and it reaches a phase change, let's say from air to water. Air and water have different refractive indices. The refractive index is a value that describes how quickly waves can propagate through a medium. A change in refractive index is what causes refraction. When refraction occurs, a wave changes in velocity, but not in frequency. This means that the energy of the wave is the same, but it travels at a different speed. This change in speed causes a change in direction. So our incident wave, like this, we would expect to keep traveling in a straight line if it were moving through air. But since it's now moving through water, its angle will look something more like this. It's important to note that this phenomenon only occurs when light enters a new medium at some kind of oblique angle. If instead it were traveling perpendicular to the water, you would observe a change in speed, but no change in direction. A common observation explained by refraction is the appearance of a straw being bent when you put it into water. In fact, the straw is straight. What's occurring is that the light from the straw reaching your eye is being refracted, so the light is being bent. This makes it appear as if the straw itself were bent.